Morning students. Today again back in the video with the part 4 of chapter atoms and molecules. In this video students we will study about the atomic mass. In the last video we have seen that how the symbols are given to the different elements. According to Dalton, atoms of the same elements have the same masses and the atoms of the different elements have different masses. So since determining the mass of the individual atom was a relatively difficult task, relative atomic masses were determined using the laws of chemical combinations and the compounds formed. You know the most in this we will see how the mass of the different elements can be measured. See, suppose this reaction we are taking example. Here we will find the value of the 1 unit mass. Earlier the atomic mass was measured in atomic mass unit. Now it is measured in unit, that is the unified mass. This which you are seeing here, this is a symbol for the mass unit. So this reaction if we take in consideration, you know that carbon plus oxygen forms carbon monoxide. Suppose 3 gram of carbon reacts with 4 gram of oxygen, forms 7 gram of carbon monoxide. In this way, if we will see that 1 gram of carbon combines with 4 upon 3 of oxygen, and when we will calculate it, it is equal to 1.33 gram of oxygen. Means 1 gram of carbon combines with 1.33 gram of oxygen. If the 1 atom of carbon is equal to 1 unit, then 1 atom of oxygen is equal to 1.33 unit. These are not convenient. These are not the whole numbers. We need in the whole numbers. However, it is more convenient to take these numbers as the whole numbers or as near to a whole numbers as possible. While searching for the various atomic mass units, scientists initially took 1 upon 16th of the mass of an oxygen atom. You can see here, this is 1 unit, that is unified mass. They took it as equal to 1 upon 16 of the mass of an oxygen atom. Now we will consider the same equation, that is carbon plus oxygen gives carbon monoxide. If 3 grams of carbon reacts with 4 grams of oxygen, it forms 7 grams of carbon monoxide. Here 1 unit is equal to 1 upon 16th of the mass of an oxygen atom, means the mass of an oxygen atom is 1 multiply 16, that is 16 unit. So if 1 gram of oxygen, here we consider this oxygen, if 1 gram of oxygen combines with 3 by 4 of carbon, then the mass of an atom of carbon will be equal to 3 upon 4 multiply by 16, and then if you will calculate it, it comes 4 4s are 16 and 4 3s are 12, that is 12 unit. So the mass of an atom of carbon is equal to 12 unit, and in this way we get mass in the whole number. Now see why scientists considered oxygen atom. Because this was considered relevant due to 2 reasons. One, that oxygen reacted with the large number of the elements and formed compounds. Second, this atomic mass unit gave masses of most of the elements as the whole numbers. That was the reason scientists took it for the measuring mass. However, in 1961, for a universally accepted atomic mass unit, carbon 12 isotope was chosen as the standard reference for measuring atomic mass. You know that carbon is present in nature in two isotopes. One is carbon 12, one is carbon 14. Carbon 12 is much common. So this was considered for measuring the atomic masses. And the reason again is because carbon reacts mostly with all the atoms of the elements present at that time. So one atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12. And the relative atomic masses of all elements have been found with respect to an atom of carbon 12 atom. Why it is 1/12? Because if carbon atom has 12 unit mass, and if each unit considered as a measuring unit, so 1/12 the mass of one carbon atom. You can understand much better with this example. Like suppose this watermelon seller selling the fruits, and this vendor did not have any way to measure. So what he did, he divided this watermelon equally into 12 pieces, and then in these 12 pieces he considered that one piece as the one mass unit. So whenever any person used to come to purchase the fruits, he used to measure the fruits with this pieces. Suppose whether it is equal to one piece or two pieces, in that way. So this was known as like fruit mass unit, FMU. But fruits, you know that these are much big in size. So such kind of things cannot be taken for measuring the atomic masses. So that is why the relative, and this is like relative mass. So the relative atomic mass of atom of an element is defined as the average mass of an atom as compared to the 1/12 of the mass of the carbon 12 atom. Atomic mass unit, which is denoted with symbol U. An atomic mass unit is a unit used to express the relative masses of atoms. One atomic mass unit is equal to 1/12 the mass of a carbon atom. Suppose if these 12 carbon 12 atom has 12 parts, suppose. So 1/12. One atomic mass unit is equal to 1/12 the mass of the carbon 12 atom. And a carbon 12 atom has a relative mass of 12 unit, and an atom with a mass equal to 1/12 the mass of a carbon 12 atom would have a relative mass of 1 unit, simply because it is 1/12 means one part of this means 1 unit, these 12 units. So 1/12, if any atom has a mass equal to 1/12 the mass of the carbon 12, means its mass will be 1 unit. And an atom with a mass equal to twice, suppose, the mass of the carbon 12 atom would have a relative mass of 24 unit. Suppose this carbon, how to write this? Like suppose this is the carbon, and it is a naturally occurring carbon 12 atom. So this mass is always written on the in the superscript, and 6 is written, that is atomic number, in the subscript. That's all for today. Thank you.